Okay, what we just established here today is that to find the sum of an arithmetic series, and that's the key. That's actually the first thing you need to check. Is this arithmetic? If it's not, this formula won't work. To find the sum, you take the first term, which we'll call A1, plus the last term, which we'll call AN, times the number of terms divided by 2. A more common way of looking at it, I don't know if you ever look in the textbook or on a formula sheet, lots of times you'll see it written as n times A1 plus AN all over 2. The order of when you divide by 2 doesn't really matter. So either way, we're going to get the same answer. So let's look at 2 more follow-up examples. If you've done the first 3 examples, which we did, this would be example 4. 3. Let's go 6, 9, 12, 15, 18. Question 1. Is this arithmetic? Yes, this isn't in your packet. I'm just creating a couple new examples to summarize. Is it arithmetic? Yes. Common difference? 3. It's growing by 3 every time. Does it stop? Yes, it stops at 18, so it's called finite. If they had a dot, dot, dot here, that means it would be an infinite series, and you wouldn't be able to find the sum, because where would this end? Never, because the next one will be 21, 24, 27. What would happen to this number? It would continue to grow, so you couldn't find the infinite sum, all right? So here we go. One method is to just go ahead and add and add and add and see what you get. But we have a formula, so let's use it. The sum of this arithmetic formula is, it's right up there in blue, the first term, 3, plus the last term, 18, times how many terms are here? Divided by 2. So 21 times 3 is 63. So could I ask it this way? What's this? What's this? What's this? How many 21s would be there? 3. 1, 2, 3. 3 21s make 63. Good? Let's explore an odd number now. What if the 18 wasn't on the end? Example 5. 3, 6, 9, 12, 15. Now, does everybody have a buddy? No. Who doesn't have a buddy in the buddy system? Aw, poor 9. Let's see if the formula still works. You ready? The formula says as long as it's arithmetic, this should work. Ben, what's the first term? Last term? 15. How many are here this time? 5. And students sometimes get confused. They're like, okay, 5 over 2 is 2.5. Is that going to be a problem? Isn't our answer going to be a decimal if we're multiplying by 2.5? No, because what is 3 plus 15? 18. Is that even or odd? Okay, times 5 over 2? 2.5. What do you get? 45? Notice it didn't end up being a something 0.5. We're good. Is the answer 45? Let's try it. Let's do the bookend method. Let's add 15 and 3. 18. 18. Is 9 significant relative to 18? It's half of it. So when I say, how many 18s do you see? I see 1, 2 and a half. 2 and a half 18s. Okay? So it works whether it's even or odd. As long as it's arithmetic, this formula will work.